Hello, this is moles video number 2, calculating the number of moles. This is AQA Chemistry Specification 4.3.2.1. Right, from video 1, hopefully you've picked up exactly what 1 mole means. It is 6.02 times 10 to the 23 of anything. Literally anything. If you have 1 mole of pizzas, you have 6.02 times 10 to the 23 pizzas. That is a lot of pizza. 1 mole of any element is the mass in grams that is the same as the relative atomic mass, which is the mass number that's given on the periodic table. So you get this given to you in the exam. So this is just the slightly more technical term for atomic mass. So you look any of these up. So if the examiners ask you what is the mass of 1 mole of helium, you look it up in the periodic table and it equals 4 grams. Try yourself if you want for neon. 20 is the atomic mass, so therefore 1 mole of neon is 20 grams. Now hopefully the summer exams will be nice and easy, and they will simply say to you, what is the mass of 1 mole of any element? You'll look it up, you'll take the mass number, which is always the larger number, and you'll turn it into grams. But you might not get that lucky. And so we need an equation for when questions ask us about a number that isn't just straight from the periodic table. The phrase, the term, that actually is referred to by moles is what's called amount of substance. It's basically a posh way of saying how much stuff have you got. And we measure the amount of stuff in moles. And the way to do that, amount of substance, is the sample mass, which is measured in grams, divided by what I'm going to call the molar mass. That simply means the mass of 1 mole. Yes, that's an R. And this is grams per mole, as in it's the amount of grams in 1 mole. So up here, that would simply be the molar mass of neon is 20 grams per 1 mole. Now I'm going to use not this whole written equation, instead I'm going to use a little shorthand for it. Mole to mean the number of moles. The mass we're going to do as a lowercase m, and then the mass of 1 mole I'm going to do as a capital M. Now you will see this in a few different ways, in different textbooks, different worksheets and so on. If you've got an atom just for one element, then they will use A and a little r. The little r means relative, and all that comes back to being relative to carbon 12 that I talked about in video number 1. So basically A for the mass of the atom. Same thing, mass that you're given, mass of a mole. And if it's a compound or a molecule, they will use the molecular mass. And there's the big M, the little r being relative. I'm just not using the little r. This one's what I'm going to use here, but you could use either of these two in the same way. So, let's try it out. Here's my equation. If you want to pause and give these a shot yourself just now, go for it. So, the question in the exam asks, how many moles are there in 48 grams of? And then I've just picked 3 elements of the periodic table. They probably won't tell you the mass of 1 mole in the question. You have to look this one up. And that's where people come unstuck. They see this mass, but they don't realise they have to look that part up. So, sample mass is the one given to us. So that is 48. The mass of 1 mole, well, it's just 12. So if you had 48 grams of carbon, 48 divided by 12, you've got 4 moles. If you want to try the next two now, do it. Again, the sample mass is the same. It's going to be the same for all 3 of these, because I've said it's 48 grams of 1, 2 and 3. Magnesium atoms are twice as heavy, twice as massive as carbon ones. So we're not dividing by 12, we're dividing by 24, and that one is 2 moles. You might not get such nice easy sums in the exam. I've picked these so I can do them in a video and remember the maths for it. It's a Sunday morning here. This one, again it's 48. I'm going to divide by 4 this time. 48 divided by 4 is 12 moles. Hopefully you all got the hang of that. So here are 3 slightly more complicated ones, because they're to do with compounds. If you want to pause and try them yourself, I'll go through them, obviously, right now. So for the first one, 4.5 grams is our sample. Oh no, I'm not given this. So I look at the periodic table. One oxygen is 16, one hydrogen is 1, but there's 2 of them. So it's 2 times 1 plus 16, that equals 18. 4.5 divided by 18 is 0.25 moles. And you can put moles or mole. Next one down. Sample mass, 4.4. Oh no, we haven't been given this. Oh yeah, we'll look it up in the periodic table. Carbon is 12. Oxygen is 16, and there's 2 of them. Add all that together. It's 44, 0.1 moles. Right, there is something you have to be careful of here. This is the examiner's favourite trick. We've been using grams, but here the question is given you in kilograms. So it's 1,000 kilograms per gram. So it's 585,000 grams. And they do this and people panic and they think the number can't be as big as it is. Sodium is 23. Chlorine is not 58.5. My apologies. It's 35.5. And that adds up to 58.5. And therefore, as you can see, the total for this is, that'd be 10,000. Okay, keeping on going. They might twist the question round on you. Instead of asking you how many moles there are in something, they might ask you, what is the mass of? You can take the equation we had before and put it into a triangle, or you can just rearrange it, whatever one works best for you. Sample mass is going to go on the top, number of moles in the bottom left, mass of 1 mole in the bottom right. So now we're being asked what is the mass of. You mean what is the sample mass? So we want to take the one from the top, and it's simply the number of moles times by the molar mass. So in these 3 questions here, again, if you want to pause and try them yourself and then review your answers. What is the mass of 3 moles of? Each one of these, we're going to multiply 3 by whatever we get the molar mass to be. So for the first one, helium has a mass of 4. 3 times 4 is 12 grams. Now, gold, you'd look it up in the periodic table, you'd find it's 197. So you do 3 times 197, and that is 591 grams. It's a huge amount more because each atom is much, much bigger. A little bit trickier here. O2, you need to remember there's 2 oxygens, so therefore it's 2 times 16, and that's 32 grams. So 3 times 32 is 96 grams. Here's another one, again if you want to pause and try, it's the same question but just trying out for a slightly more complicated thing. 1 carbon is 12, oxygen 16 but there's 2 of them, so that equals 44. So we're going to do 3 times 44, and that's 132 grams. Final way of doing it. You've seen how to do it to get mass, you've seen how to do it to get the number of moles. What about to work out the identity of the mass of 1 mole? Now if they tell you the element or the compound, you can look it up. So the way these questions would be written is something like this. Elsie has 1.2 grams of a mystery metal. You're told how many moles this is, 0.05, so you've got to identify which metal it is. Now you know you've always got to be looking at the periodic table. So we're going to rearrange the equation from above. To find the identity of something, you need to find the mass of 1 mole. If you want to have a try now, go for it. So 1.2 grams is our sample. The number of moles is 0.05, and so that gives us 24 grams for every mole, which if we look in the periodic table it's magnesium. Thank you.